12:30. All right, folks, so we are on page 5 in the notes, and we are going to be factoring trinomials today. So this first one is just a good old quadratic, like we did a bunch in Unit 4. And what's the first thing we always check for when we're factoring?
GCF.
GCF, do we have one?
No.
No. Okay, so there's no GCF that we can take out. Is this sum or difference of cubes or sum and difference of squares?
Square.
Well, x squared is a perfect square, but then I've got this x, which is not a perfect square, and 6, which is also not a perfect square. So let's just go back for a second. In order to have sum and difference of squares, sum and difference of cubes and difference of squares, there will only be 2 terms. So if there's any more than 2 terms, if you've got ax squared plus bx plus c, or if you've got this full quadratic, it's not going to be one of those special cases. So it's not sum and difference of cubes. It's not difference of squares. There's no GCF. So now we move into the x method, which is when we are looking for a product of the first term, a product of the last term, and a sum of the middle term. Now, folks, you are free to use just straight up guessing and checking, but if you're looking for a systematic way of finding the factors, I do think the x method is pretty slick. So let's start with this first term. What are 2 factors of 2x squared? 1x and 2x, 1 and 2. Then what about possible factors of 6? 3 and 2. You can do 6 and 1 as well. So this is where kind of the guessing and checking comes into play. So the reason why it's called the x method is we are going to multiply crisscross. 1x times 2 is 2x. 2x times 3 is 6x. And then is there any way for me to get a sum of that middle term by adjusting the sign of these two? That's, if I make them both negative or one of them negative, yeah, that's a no. So that's out. Let's go ahead and flip them. Let's try 2 and 3. 1x times 3 is 3x. 2x times 2 is 4x. Is there a way for me to get a sum of negative 1 with these two? Yeah, who needs to be negative?
4.
The 4, so who needs to be negative here?
2.
The 2, so that 2x times negative 2 will give me negative 4x. So don't forget, folks, because this is something that trips up the pre-calc kids. After you adjust the signs, make sure you are getting the right product number sign. Is negative 2 times 3 negative 6? Yep. So we're good to go there. So at this point, we have solved the factoring puzzle, and now we are ready to write the factors. Though these are part of our factoring process, those below numbers aren't the factors. The factors come from the corners of the x going straight across with each other. So the 1x gets paired with the negative 2. So x minus 2 or 1x minus 2. And then the 2x gets paired with the positive 3. And it feels kind of backwards. It's like, wait, but we don't actually multiply those together in the x method process. We don't actually multiply those together when we FOIL either. So you may remember back in the day, we said that these numbers represent the F part of FOILing. This is the O part of FOILing. That's the I part of FOILing. And this is the L part of FOILing. So if I were to check myself, x times x, 2x squared. There's the F part of FOILing. Outside terms, x times 3, 3x. There it is. That's the O part of FOILing. Inside terms, negative 2 times 2x is negative 4x. And the last terms, negative 2 times 3 is negative 6. And there we have it, F-O-I-L, the 4 parts of FOILing. So that's why this process works, and that's why we put the 1x and the negative 2 and the 2x and 3 together in parentheses, because I don't actually multiply those terms together when I am FOILing. So this is my final answer. This was the check. Do we have to show the check? No, but if you don't like factoring, it's not a bad idea to try it to see if you get the right polynomial that you started with. So now we're going to look at B. Before we start going, oh no, it's got a degree of 4. This is not a quadratic. This is a polynomial. This is something new. What is the first thing we always check for? Do we have one? Yuppers. So go ahead and take that 2 out. And that leaves me with x to the 4th minus 10. Let's try that again, Cairo. 10 x squared plus 9. Now, my name for these that have a power of 4, a power of 2, and then a constant, or ax4 plus bx squared plus c, I call these fake quadratics. Fake quadratics. They're not actual quadratics. It's not ax squared plus bx plus c, but we can still deal with them a lot like we do with regular quadratics. Can't use the quadratic formula on them, but we can factor them using the x method. So I'm going to approach this in the same way I approached the last problem. We need to get a product of x to the 4th. What do you think we should use to get x to the 4th? X squared and x squared. Just like for a quadratic, we have x and x. For a fake quadratic, we have x squared and x squared. Then what about a product of 9? Looking at my sum number, which we want to be negative 10, what do you think we should use? 3 and 3 or 9 and 1? 9 and 1. So let's use 9 and 1. Multiply on the x, and we get 1x squared and 9x squared. So if I need those to add up to be negative 10, who needs to be negative? Both. So both of those guys are negative. Both of those are negative, and make sure the product number is good. Is negative 1 times negative 9 a positive 9? Sure is. So at this point, we have factored it. So x squared gets paired with the negative 9. X squared gets paired with the negative 1. But wait, there's more. So x squared minus 9, x squared minus 1. Folks, what's the first thing I'm missing as far as this full factorization goes? The GCF. So bring on down that 2. It's part of the factorization. Now, when I said, but wait, there's more, we can actually factor this further. Is anything jumping out at you about x squared minus 9? They're both perfect squares. So, folks, this is actually difference of squares. So I'm going to have the 2 still. And then perfect square factors of x squared, x and x. Perfect square factors of 9, 3 and 3. One gets a plus and one gets a minus. So, taking it down a little bit further. Besides, you need a notepad.
Yeah.
You need, okay. So what about x squared minus 1? X squared is a perfect square. Folks, is 1 a perfect square? It's kind of elusive, and if you go back to that yellow sheet that we've referred to a few different times, it wasn't explicitly on there. The reason why is because when we're simplifying square roots, taking out a 1 doesn't really help us, but 1 is a perfect square number. So this is actually difference of squares as well. I would put a star by this. That's probably one of the more elusive setups of difference of squares that you would need to factor. So perfect square factors of x squared, x and x. Perfect square factors of 1, 1 and 1. 1 gets a plus and 1 gets a minus, and holy cow, take a look at our factored form. What a mess. So we always want to make sure that after we've taken out a GCF, we try to factor. After we factored using the x method, we try to factor. We always want to make sure that we are as factored as possible. So folks, with that in mind, I want you to see what you can do with problem C. Is there a GCF? Is it sum and difference of cubes? Is it difference of squares? Or should we use the x method on that fake quadratic? Go. Is there a GCF? Mm-mm. Is that a fake quadratic? It goes 4, 2 constant, so we can go x squared. Ooh, let's see, factors of 8. Let's do 2 and 4. Multiply on the x, we get 4x squared and 2x squared. So if I need my sum to be negative 2x squared, who needs to be negative? The 4. So who needs to be negative up here? The 4. And remember, we need to make sure we're getting the right product number. 2 times negative 4 is negative 8, so we are good to go there. So our factors go straight across. X squared with the 2, x squared with the negative 4. X squared plus 2, x squared minus 4. Can we factor it a little bit further? Yeah, why? Difference of squares only with the second parenthesis. So we'll have that x squared plus 2. Perfect square factors of x squared, x and x. Perfect square factors of 4, 2 and 2. One gets a plus, one gets a minus. And that's our factored form. Any questions so far? Ooh, let's take a look at problem D. Do we have a GCF? 3? No. 4? Nope. 23? That's a prime one, so we're stuck with those items. So folks, this is a great problem to practice the X method on. I would start with your factors of 2 and 3. So then 2x squared and 3x squared for the product of 6. For 20, let's try 4 and 5. I normally start with the factors that are closest together, especially if I can't tell just from looking at that middle number like I could on this one that I should use 9 and 1 for the 10. So always good to start with the numbers closest together. So multiplying on the x, we get 10x squared and 12x squared. Oops. Well, that just hurts my feelings. Is there any way for us to get 23x out of that? It's so close. Big tear. So hopefully switching the order of these around will be enough to get us to exactly 23. So 2x squared times 4 is 8x squared. 3x squared times 5 is 15x squared. Sweet. Keep the signs positive. That will give us that sum of 23x that we want. And that means these signs are going to stay. And do they give me the sign of positive 20? Sure do. So then the 2x gets paired with the 5. The 3x gets paired with the 4. So 2x squared plus 5 and 3x squared plus 4. Now, if you're looking at those going, we've got quadratics as factors. They are only two-term quadratics, though. Folks, the only time you can factor two terms, so there's that two terms here, is if it is difference of squares, difference of cubes, or sum of cubes. Are either of these difference of squares? They're both addition. Are either of them cubes, sum, or difference? No. So if it has two terms and there's no GCF, and it is not one of those special cases, we're done. Throw a box around it. That is your final factored form. Any questions so far? All right, it's time for our last method of factoring. Factoring by grouping. The big thing with grouping is the identifier. Grouping factoring always needs to have 4 terms. So as we can see, there are 1, 2, 3, 4 numbers here, 4 chunks here, 4 chunks there. So 4 chunks for all of these. So 4 terms automatically means grouping is going to be the only way to do it. After you have identified it as grouping, you are going to split it in half and take out GCFs. From both groups. Then you will have the same parenthetical item in one parenthesis and the GCF plus GCF in the other parenthesis. It's more of a visual process than this written out in word procedure that we've tried to write, so I promise once we do one of these it will kind of make sense what all of that stuff means. So let's go ahead and just jump right into problem A. So as we're looking at this first one, we have 4 terms. We have to have 4 terms in order for us to split this equally in half. So split it in half. We got 2 terms over here. We got 2 terms over there. After we split it in half into 2 groups, we're going to take a GCF out of this group and a GCF out of the other group. So what is my GCF for group number 1? 2. So we're going to take a 2 out. And that will leave me with x plus 1. That sometimes throws students off that it's x plus 1 and not x plus 0. When we take out a GCF, we want it so that if we were to redistribute that back out, we would get the same expression we started with. So 2 times x, 2x. 2 times 1, 2. So that's why we need that 1 kind of as a placeholder there. Oof, that hurt my eyes. All right, folks, looking at our second group, what is our GCF? 3y. Excellent. So we can take a 3 out of both of those. So 3y. And when I take out that GCF, we are left with x plus 1. So we take out a GCF from both groups. And now we have an expression with 2 parts that are the same. Folks, what we're essentially going to do next is we're going to take out that x plus 1 as a GCF from both of those terms. So if I take out this x plus 1 as the same GCF unit for both, then what are we left with if we take an x plus 1 out of this? A 2. What are we left with if we take an x plus 1 out of that one? A 3y. So conceptually, you take out a GCF from the first group, a GCF from the second group, and then we look at this expression as a whole, and if these 2 expressions are the same, we can take that out as a GCF, which leaves me with the other 2 GCFs in the other parentheses. If you want to more just visualize it, we get the same unit, it is the same, and these terms go down into the second parenthesis. And we're done. It's factored. Because now instead of having something plus something plus something plus something, we now have something times something else. Let's go ahead and take a look at B. So how do we know that this is grouping? Or the potential to be factored by grouping? There are 4 terms. So we are going to split it in half. And we're going to take a GCF out from the first group and a GCF out from the second group. So what's my GCF number-wise for 12 and 4? 4. So 4 and then an x squared. Wonderful. The biggest number and the biggest variable that we can take out of both. So take a 4x squared out. That leaves me with 3x minus 1. Now looking at these 2, what can I take out of 15x and 5? A 5. Now if I take out a 5, that would leave me with negative 3x plus 1. What's the problem here? They're not the same. So this is not the same. So I wouldn't be able to take the 3x plus 1, or sorry, the 3x minus 1 as a GCF out of full. But you know, they're pretty darn close to being the same. So instead of taking out a positive 5, what could I take out to get them to have the exact same unit? A negative 5. So if I take a negative 5 out of negative 15x, we get a positive 3x. If I take a negative 5 out of positive 5, we get a negative 1. So now that I have the same parenthesis, I can take that parenthesis out as a GCF, the whole thing, 3x minus 1. And when I take that parenthesis out as a GCF, we're left with the 4x squared and the minus 5. So again, we're taking out that green part as a giant GCF from the whole expression. On your own, I want you to try C. So 4 terms, split it in half. GCF from the first pair, 3x squared. So leaves me with 4x plus 1. GCF from the second pair is a 7. Then I can take out that 4x plus 1 as a GCF out of both of those, 4x plus 1. And that will leave me with 3x squared plus 7. All right, folks. Any questions on the X method? Any questions on grouping? All right, then. Just as a quick reminder, in your homework packet, page 4 is due tonight. Hopefully you got almost all the way done with that. For tonight, we are going to be working through number 53 on page 5. So there's more factoring problems on there. So I think, folks, before lunch, I'm going to give you some time to practice these problems. Whoa, there we go. So we've got fake quadratics on 47 through 50. And then we've got grouping. Sorry, this is the purple packet. It does look kind of blue on the screen. So this is the purple homework packet. So hopefully you already have through 46 done. Page 4 is officially due tonight on Canvas. And you now have what you need to do 47 through 53.